Start.
Morning, doctor. My name is Jacqueline, and this is my paper, which is enhancing IU fishing risk assessment in the South China Sea using graph attention network on vessel encounter data. And my supervisor is Dr. Nina Alfred. So just a recap from the FYP proposal, my problem statement is that current machine learning approaches for IU fishing analysis often analyze each vessel separately, which limits their ability to identify coordinated suspicious activities. And so my research question is, how can AIS derived vessel encounter events be used to construct a vessel interaction network, and can a graph neural network learn patterns of suspicious behavior from both vessel attributes and vessel encounter relationship, and does a network-based model using vessel encounter relationship identify suspicious vessels more effectively than machine learning models that analyze vessels individually. And my research objective is to construct a vessel encounter graph for the South China Sea using encounter event data, and to develop a graph attention network model that learns from both the vessel attributes and the encounter relationship, and to evaluate whether the graph-based model identifies the vessels with known IU risk indicators more effectively than the baseline, which is XGBoost. And my research gap is existing AIS-based methods mainly analyze vessels. Sorry. Okay. So my research gaps is that existing AIS-based methods mainly analyze vessels individually, and existing approaches does not fully model the vessel encounter relationship as a network, and it remains unclear whether the network-based model can identify the suspicious vessel better than the individual vessel using ML models. Okay. So my research direction is a graph-based approach where vessels are represented as nodes and counter relationships are represented as edges. And these are my scopes, so I am only focusing on the South China Sea, and I'm using Global Fishing Watch as my data source, and my time period is from 2021 to 2024, and these are all the regions covered, and this is excluded from my study. So currently I've done all this, which is data collection, data preparation, feature engineering, experimental input, as well as all the model training and ablation analysis, and I have evaluated and compared. And from my data collection, I've collected 256K encounter data and 13K AI escape data, and loitering data is 1 million. Okay. So for this study, I am only using encounter data as the main data set, and these two are only the supplementary data. And from that collection, I clean it by removing duplication, replacing the missing flags with unknown, and validating the timestamp and duration, as well as capping the 99 percentile for extreme values. And from there, I got the clean brackets. And then I did feature engineering, so I created a few more features for the upcoming CRI calculation, and I aggregated. I combined the dataset, and then I aggregated the dataset so that each row is only one vessel. So I got 26K vessels, and I have 43 inputs, and my hash attributes is 7. And so this is just the EDA from here. Since I'm only focusing on After the aggregation, I filtered the dataset so that it must include encounter. So the encounter is of course dominating, but since I'm doing regression, I did not do any class balancing method. And the behavioral features, as you can see here, is quite skewed. That's why I chose to do percentile based CRI scoring. So this is how I will calculate my CRI. So I have 5 components for CRI, and I will calculate the risk by average, and I will average them by equal weights. Yeah, basically. Okay, sorry. So this is the configuration for XGBoost. So this is just before the hypertuning, and this is for edge-aware GAT. And for ablation analysis, I also use the same configuration as the self-aware GAT. And after training, I actually found that the baseline model actually performs better than the graph model, which was not what I was expecting. And after ablation analysis, I also found that actually the graph did not contribute as much as I had hoped for. And so for the next FYP, I will try to see if hyperparameter tuning will actually improve that result. And if not, I want to explore more GAT based model, which is GAT-V2, as well as see if the residual helps with GAT. And I will also do K-fold cross validation and per t-test, and I will also analyze the graph and implement explainability, which could help me see why exactly that graph did not perform as well as the baseline model. And of course, I will do the prototype to visualize the risk of each vessel. Okay, that's all. And these are the references that I use.
So regarding the last things, highlight what you have addressed. Last presentation.
Wait, which one?
Last presentation. You presented last night.
Oh,
The 7th week.
yeah.
I've commented something for you to address.
Oh, yeah, the novelty.
What you have done regarding
I collected this for the South China.
the second examiner.
I already presented to Dr. She did not comment on anything. It's just that she told me that the hyperparameter tuning could take some time, so I should start during the semester break.
Terima kasih.
Thank you. Oh, no comments. No comments.
Just a little exercises for organization and growth. Oh, yeah. Yeah, that's short last time, right?
No, I think that was sure.
This short, yeah.
this to improve the tables lah.
Yeah, table and organization is nice.
Thank you, Doctor.
Title, some title there is gone, some title without gone. This is small thing. 5 minutes you can do these things. Okay?
Thank you, Doctor. Organization report.